Welcome to this presentation on Java programming. Today, we will learn how to check whether a number is a palindrome using a user-defined function in Java. We will reverse the digits of the number and compare it to the original to determine if it's a palindrome. Let's begin by understanding the problem statement. We need to write a program that accepts a number from the user and checks whether it is a palindrome. To do this, we will define a function named reverse that returns the reversed number. In the main program, we will compare the original number with the reversed number to check for palindrome. Here is the step-by-step algorithm to solve this problem. First, we start the program. We define a function called reverse that accepts an integer and returns its reversed form. Inside the function, we extract digits one by one using modulus and rebuild the number in reverse order. In the main method, we read the number from the user, call the reverse function, and compare the result. If the original and reversed numbers match, we display that it is a palindrome. Otherwise, it is not. Finally, we end the program. Now let's take a closer look at the core of our program, the reverse function. This method is declared as static because it is being called from the main method, which is also static. In Java, a static method can be called without creating an object of the class. The function takes one integer argument, n, which is the number we want to check for palindrome. We initialize a variable rev to 0. This variable will store the reversed form of the number. The while loop runs as long as n is greater than 0. In each iteration, we perform 3 steps. First, we extract the last digit of the number using n and store it in the variable digit. Second, we multiply rev by 10 and add digit to it. This builds the reversed number one digit at a time from right to left. Third, we remove the last digit from n using integer division by 10. Once the loop ends, we return the final value stored in rev, which is the complete reversed number. This function cleanly separates the logic for reversing a number, making the code reusable and easier to debug. Here is the main method that drives the program. We start by creating a scanner object to accept input from the user. We store the input in the variable num and pass it to the reverse function. We store the returned value in reversed and compare it with num. If both are equal, the number is a palindrome. Otherwise, it is not. Finally, we close the scanner to release the input stream. In this slide you will get the full program link which you can execute the entire program. Also program link is available in the description box. This table explains the variables used in the program. N is the number passed to the reverse function. Rev stores the reversed number. Digit holds the last digit during each iteration. Num is the original number entered by the user. And reversed holds the output from the function, which we use to check if the number is a palindrome. Here is how the program works. When we enter 121, the reversed number is also 121, so the output confirms it's a palindrome. But when we enter 134, the reversed number is 431, which doesn't match the original, so it is not a palindrome. This proves that the function and logic are working as intended. Let's quickly recap what we've done in this program. We created a Java program that checks whether a number is a palindrome. The main logic was placed in a user-defined static method called reverse, which reverses the digits of the number. We used a while loop to extract and reassemble digits in reverse order. The main method took the user's input, called the function, and compared the original number with the reversed one. If both were the same, the number was declared a palindrome. We also included a variable description table to clearly understand the use of each variable in the program. Before we wrap up, let's go over some important takeaways. First, static methods can be called directly from the main method without needing an object, making them convenient for utility tasks. Second, organizing your logic into functions improves clarity and reusability. Third, when working with numbers, the modulus operator helps extract digits, and integer division helps remove them. Always test your program with both palindrome and non-palindrome inputs to ensure correctness. And finally, remember to close resources like scanner objects to avoid potential memory leaks and maintain good coding hygiene. Thanks for watching. Documentation containing question, algorithm, Java program, variable description table, VDT, sample output is also available in description box of this video. Don't forget to subscribe if you are using this for your school or college projects. Happy learning!